In this video, I will show how to express a limit as a definite integral. So this theorem states that if f is integrable on the closed interval from a to b, then the integral from a to b of f of x dx is equal to the limit as n goes to infinity of the sum from I equals 1 to n of f of xi times delta x, where delta x is equal to b minus a over n, and xi equals a plus I times delta x. Right, so this basically shows that if we have a curve and we're finding the area underneath this, we can add up an infinite number of rectangles under this curve. And that would be with our height f of xi and the width delta x. And here our interval would be from a to b. Right, and once again, n is the number of rectangles that we have. So that's why we want n to go to infinity, because ultimately that is going to create that integral for us. The more rectangles we have, the more accurate the area we have under the curve. And our xi is just some x value that we arbitrarily choose on our x-axis between a and b. So here in this theorem, it just shows us how the integral is the same as this summation as the limit goes from n to infinity. Alright, now I'm just summing up a little bit of what I said, just that we are adding up an infinite number of rectangles to get the area under f of x. Alright, and for the first example, we have the limit as n goes to infinity with the sum from I equals 1 to n of cosine xi over xi times delta x. And our interval here is going to be from pi to 2 pi. Now we want to convert this to an integral. So from the start, we know that our a and b are going to be pi and 2 pi respectively. We know that our delta x is going to become dx when we convert it to an integral. We also know that this is our f of xi function here, the cosine xi over xi. So all we need to do is replace our xi with an x. And now this first part is going to be converted into the integral symbol. And we'll have our limits of integration from pi to 2 pi, because that is our a and b. So now I have the integral from pi to 2 pi of cosine x over x dx. And that is our final answer. Right, now for the second example, I'm going to go in the opposite direction. I want us to express this integral as a limit. And this is going to be a limit of Riemann sum. So we have the integral from 2 to 6 of x over 1 plus x to the 5th dx. So we know off the top that we have our a and b to be from 2 to 6. We know that our dx is going to be converted into delta x. And that first portion is our f of x function. So we'll replace our x values with our xi value. And remember from the theorem that xi equals a plus I times delta x. So that means that'll be 2 plus I times delta x, where delta x equals b minus a over n. So plugging in the numbers, we get delta x equals 4 over n. So now our xi equals 2 plus 4i over n. So this integral symbol is going to be replaced with the limit as n goes to infinity with our sum from I equals 1 to n. And now we will have xi over 1 plus xi to the 5th times delta x. Now plugging in our terms so that we have everything in terms of I. We are going to replace delta x with 4 over n, and then we are going to replace the xi with 2 plus 4i over n. So now just substituting these terms, we will see that we'll get the limit as n goes to infinity of the sum from I equals 1 to n of 2 plus 4i over n on the numerator over 1 plus 2 plus 4i over n in parentheses to the 5th times 4 over n. And that is going to be your final answer.